And here next example for the hairpin primer probe is nothing but the light upon extension. Okay, in this technology, one of the primers is labeled with the fluorescent fluorophore close to the 3' end, that is quenched by the hairpin structure of the primer. And here we need to understand is, so when compared to the scorpion probe, in the scorpion probe we used to have the reporter and also the quencher. Okay, so here the fluorescent property of the reporter is going to be removed, or it is going to be avoided with the due to the presence of the quencher over there. Quencher going to absorb the energy of the fluorescent, so that here we cannot able to detect the fluorescent. But here in this case, so here even the fluorophore is attached to the 3' end of the probe, but here due to the hairpin structure of the primer, the fluorescence property of the fluorophore, it is not going to be detected. Oh, okay. So here due to the and here these probes, they do not require the presence of the internal quencher at all, because the hairpin structure itself, it is going to act as the quencher. Okay, so here the hairpin structure confers the ability to decrease the fluorescent signal when the primer probe is free. Okay, so here due to the hairpin structure, it is going to decrease the fluorescent signal from the fluorophore which is attached to the probe itself. Okay, on the integration of the labeled primer to the PCR product, it is going to fluoresce because it increase up to the 8-fold. It is because the extension of the hairpin structure. Okay, so here during the PCR, what will happen is, so here this hairpin structure will be linearizes. Okay, and it is going to be extended in the PCR process. And here due to the linearization and also the extension in the PCR process, the fluorescence, it is going to be increases 8-fold. And here the fluorescence is measured in the extension phase by using this technology. Okay, so here as I discussed earlier, these primers, they are also having the hairpin structure, and here they are going to be attached to the reporter or the fluorescent molecule. And here this is the fluorescent molecule which is attached. And here the fluorescent property of this reporter, it is not going to be detected. It is because it is avoided by the presence of the hairpin structure. And here this hairpin structure itself, it is going to act as the quencher. And here due to the presence of the hairpin structure, the fluorescence signal will not be there very significantly. But here in the process of the PCR, what will happen is, so here they undergo the denaturation. In the denaturation, it is going to be linearizes, and in the annealing, it will be comes and bind to the specific target DNA sequence in the sample. And here in the extension, so here from this probe, so here it is going to be extended by adding the complementary DNTPs. Okay, so here during the extension, what will happen is, so here the primer is going to be extended, and here in the extension, the reporter, it is going to fluoresce in the double strand DNA product. So here in the extension, so here the reporter is going to be fluoresces. It is because, so here now this primer probe, now it is not having the hairpin structure. And here once the hairpin structure is lost, and here this primer probe, now it can fluoresce, because it is now it is going to be become the part of the complementary DNA strand which is synthesized over here. And here due to the formation of the double stranded DNA over here, its fluorescent property will be increased about 8-fold. Okay, so here due to the double stranded nature of the DNA which is formed in the extension phase of the PCR, its fluorescence property will be increased about the 8-fold. And here this is how these Hux primer probes are, it can be used in the detection of the amplification process. It is because, and here when compared to the scorpion primer probes, so and here the fluorescent property of these reporters are quenched due to the hairpin structure of the primer probes. And here during the PCR, what will happen is, this hairpin structure is going to be linearized, and in the annealing phase, it will be comes and bound to the complementary DNA strand, and in the extension, it will be extended. And here in the extension, it is going to form the double stranded DNA, and here in the double stranded DNA form, its fluorescent property will be increased 8-fold, and it can be detected. And here by doing so, here these primer probes, it is going to detect it in the process of the PCR, and here we can able to monitor the process of the PCR. Okay, this is the one more example for the hairpin primer probes. Thank you.